My topic is monitoring the health of your services. I just wanted to give a little backdrop to help kind of explain how I came to this topic, because it also sheds some light on kind of what we're doing at Orion, and we're pretty excited about. I think it's it's pretty interesting work, and so we're like Chad Boyer mentioned, we're looking for talent out there. So if this is interesting to you, give us a shout. But so one of the things that we're doing is, we have our primary application is a monolith, and we're looking to, like many organizations, break it out into more of a service oriented or microservice architecture. And part of doing that, as part of the enterprise architecture team, we're looking at all the kind of the infrastructure things that go along with that. We want our 14 development squads, when they are architecting a new solution, we want them to think cloud first, service oriented first, instead of where we're at today, where, okay, add it to the on-prem monolith. And so that's one of the, I think, the really interesting things that we're doing at Orion. And so we've got a lot of like infrastructure type things that are common across all of these. When we turn this over to 14 squads, we want to have these things figured out. So, basically for them to go, hey, it's really easy for me to stand up a brand new service. It's a couple clicks and boom, I've got my Hello World service running. Now I just put in my implementation. And one of the key points of that is observability, which is a few different things, but the big one that we were going to focus on tonight is the health check API. And so some of our goals, again, this is kind of a fun exercise that we're going through, because a lot of these things, all of these things, they apply to monoliths, but they're kind of one and dones. You figure it out, you implement it, and you move on. Where this is kind of taking us back to, okay, let's revisit all of these things, because now we're going to have to reproduce it every time we stand up a new service, and we want 14 squads to stand up brand new services for their solutions. That's what we want to be their go-to. That means all these things got to be figured out. So we're kind of taking another look at it from more of a service-oriented architecture type point. So with health checks, so some of our goals of that is detecting that if a service is unable to handle requests. If so, an alert should be generated when the service is failing. If the service is failing, requests should be routed to a working service. And whatever we use for the health check, it should be extendable for things that are unforeseen. We want to make sure we can support whatever's coming in the future. And then also an easily repeatable pattern for all developers and services.
Hey Ben, sorry to interrupt.
Yeah.
I think you're displaying your presenter screen, so we see the presenter view. Is that what you intended? And the slide is really small.
No. Okay. No, thank you.
Yep.
So let me fix that. Oh, I see. Okay. Thank you. Well, that didn't go along very well with what I was saying, but okay, yeah. So we're looking at the health check API, looking at these goals that I mentioned, and yeah. So that brings us to the demo, which is this GitHub library, the ASP.NET Core Diagnostic Health Check. All right, let's see. Just a second. Yeah, Teams a little different. All right. Okay, there we go. All right, so what I put together as a demo is a nightlife application, and I apologize I did not get the UI done, but um, uh, imagine you have an application, and really what I want to show is these underlying services of the application. And so I've got a nightlife application, and the intent of this is like you're going out for the night, and we need a few things. So first of all, we need the weather. This is just this simple. This is pretty much the like when you start up a .NET Core, it's kind of the template that they give you. So this one's the weather. This one gives you drinks, so we can find drinks and the recipes for the night. And then we need dad jokes because we are entertainers. And so yeah, my UI for this is basically going to be Postman. Let me see. I can't just share a screen. Oh, there we go, desktop. Huh. Okay. So Postman, since I didn't get the UI done, so I've got the weather service, which just returns the forecast. I've got a drink service where I can put in a drink name and return that drink and the instructions to create that drink. And then I've got a dad joke for some good material for the night. And I'm going to read a couple of these because they're really funny. I used to have a job at a calendar factory, but I got the sack because I took a couple days off. How can you tell a vampire has a cold? They start coughing. Okay. All right. So I've got my services, and then I can create my application. Okay. So I've got my application that relies on these three services. And now we're going to implement the health check middleware. We'll start out with our dad jokes API. And what we're going to do is we're going to configure. So like a health check API, basically it's an API endpoint that we can hit, and we can it will return if that service is up and running or not. And there's a few reasons we want to do this. One is, it's good use for load balancers to know that your application's up and accepting, or if it needs to direct traffic to something that is running. But another thing is to create kind of a UI or a dashboard, especially when you get into having, tens or hundreds of these services. We really need to be able to have that observability into them and see if any of them are having issues. And so what we'll be looking at doing is, first of all, having each of these three APIs report their health status. And then once they're reporting their health status, we want to build a UI that shows kind of a dashboard of that health status. And this library, there's a NuGet package for this library of the ASP core diagnostics health checks that does an excellent job of this. I was really excited when we found this. It's pretty extensible, and it's all middleware. So it just takes a little configuration to get it up and running. So we'll start out with this dad jokes API, which again, it's just an endpoint that returns good old dad jokes. And we'll go into the startup, and this is where we'll start implementing some of that middleware. So I've already installed the NuGet package. So at this point, I'm just going to configure the services. And so all I need to do here is add the dependency injection for the health check. So that's it for that. And then in the configure method, we'll configure the endpoint. So this is basically, we want a /health as one of our API endpoints, and we're building that in the middleware. So we can configure that here. With the map health checks, which is also part of that NuGet package. And you just give it the endpoint that you want to use. So now our service will, so if we build this, and go back to Postman. Now I've kind of configured that /health endpoint, and if I do a get on that /health endpoint, I get a healthy, and that's it for now. So pretty cool, not too exciting, but kind of cool. Okay, and then all right, so here it's also important to note that we can add additional endpoints, which I'll show in detail in a minute, but that can be really useful because we can add, that just returns a simple healthy. You could do stuff with that, but we can do a lot more with it. So we'll come back to that. And just as a side note, there's also some configurations you can do here, such as require host, require cores, and require authorization. So if you want to lock down this endpoint more, then you can. So like require host, if you wanted to say, okay, only return the health of this endpoint if it comes from this host, you can do that. If you want to require authorization, you can do that. Normally in an API, you would do that with the authorization attribute on the endpoint, but here, since you don't have one, you can do that using this require authorization. So there's a couple other things there. We're not going to use any of those right now, though. All right, so now we'll see how to, now we'll go a little bit deeper. We'll see how to go a little further than just returning a healthy. We also want to look at dependencies. So basically, this service, and as many services, usually they're going to be reading from a database. Maybe they're using Redis cache. Maybe they're using some other APIs. So we want to not only return healthy based on if this service is running or not, but also, hey, are any of the dependencies failing? That's good to know. So this is also done in the startup class, where we'll just extend our add health checks service to include other additional checks. So we can just do add check here. We can give it a name. So like in this example, this is the dad jokes API, and basically this calls out to just somebody's service that I found out there in the world somewhere to get those dad jokes. And so, basically this is a dependency of my service. If this service is down, then my service is down. So that's where we can check to make sure that that service is up before we say that we are healthy. So I can say, I just give it a name here, external joke API. And then here I can do whatever I need. So I can create a lambda basically to indicate if that service is up and running. So basically I want to check and see if this service is running. Let me see. Shoot. All right, so I can go ahead and write that code here. You know, something like so yeah, I can new up an HTTP client. Oops. Okay, and assuming it works, then I can just return a status of healthy. And then if there's an error, instead of throwing an error, I can return health check status unhealthy. So that would be one way to implement this. And so that will basically ping this service. And if it's successful, it's going to respond with a healthy. Otherwise, it'll respond with an unhealthy, which is great. One of the really cool things, though, about this library is they have a lot of these health checks pre-built. So, you know, I kind of wanted to show this because you can see the extensibility. You can obviously wrap anything that your application might have, whether anybody else uses it or not. It's completely custom. But one of the cool things is they do have all of these health checks as NuGet packages. So like if your dependency is SQL Server, they've got a package for that. You don't need to test it, or you don't need to write it. You know, you can see all of these. It's just a lot of them. So kind of the one that I'm doing right now, where I'm kind of testing another API or a URL, is this URI single user or this URI test. And so rather than writing it custom like I just did, instead, I can install the NuGet package that goes along with testing URIs, this one here. So instead of writing my own custom, I'm going to use the one that they've provided, and this takes the URI. Oops. And then it also takes, just give it a name. So this is my external joke API. And finally, we can tell it what state to return if it fails. So this is nice because you might have like maybe Redis, your application won't fail, but it's slower, or maybe there's, you know, something that's not critical to the application. Maybe you'll just have, so you might have a reason to specify degraded as opposed to unhealthy, but here we're going to use unhealthy. Okay. So now what that just did then is not only am I checking to make sure my service is running, I'm also checking to make sure this service is running. And like I said, you just keep adding. So if you use a SQL Server, then install that NuGet package, and there you're gonna, you know, it's gonna check that your SQL Server is up and running. And like I say, they've got packages for Redis, for DynamoDB, for just tons of things. So you can always write your own, but there's a lot already out there. All right, so now we'll take a look at how to format the the response. So as I showed just a moment ago, this returns a healthy, unhealthy. You could do some stuff with that, but what we really want to do is use the information that this health endpoint returns and build a dashboard. And so we're going to look at trying to get more information than simply healthy, unhealthy. So for this, there's another NuGet package, which is, again, it's part of this, but actually, let me just show it this way. Okay, we've got this UI client. And so what this is going to allow us to do is, well, I'll show you. So in the startup, or in the startup, under this endpoint configuration, we can configure not only the endpoint, but we can also configure what the output looks like instead of just saying healthy, unhealthy. Okay, so that is in this health check options class, new. And here we can specify a response writer. And here, just for the sake of completeness, you can write your own. So I could take this and basically it's going to take a HTTP context and a report. So in here, I could evaluate my health tasks, and I could respond with any JSON in the response I wanted to. But one of the cool things is they also in this package, in this healthcheckui.client, they have one that is built for an out-of-the-box UI. Which is this guy. So I'm going to use the one from the NuGet package as opposed to writing my own. All right, and then we'll take a look at what that looks like. So what does that do to our health endpoint? Instead of just returning the verb, the word healthy or unhealthy, okay, so now I get a nice JSON structure, and it's got a little more information. And I'll go into this a little bit more in just a second. But now we're writing JSON, something that can be consumed by a UI in a client. All right, so now we're going to build a UI for this dashboard, and I'm going to build that right into my application. So if I had put more effort into this, I'd have this application is a nice nightlife UI with drinks, forecast, and dad jokes. But instead, I kind of have the blank template page. But what we're going to add to this would-be application is a health UI, where we can see the services that are feeding this application and see the statuses of them. So in that application, this is my web application, the UI side. In the startup, I can come in here and I left it in here. So again, I've installed the NuGet package. Both the Health Check UI client and the Health Check UI. And that's going to allow me to add kind of this out of the box dashboard into the middleware without actually writing it, which is pretty cool. So the things I'm going to do is I'm going to add the health checks again to my services, and then also different from those other services is I'm also going to add my health checks UI. And then we also need to add some kind of storage. That can be a number of different things. In this case, I'm going to use in memory. And then in the configure, I just tell it to use the health checks UI to map those middleware endpoints. And that's it. And so now when I start this up, I'm going to go to this health checks, which is the default. You can obviously change that, but the default is health checks for the middleware, and this UI pops up. And oh, one more thing that we have to configure is there is this use health checks UI has some application settings in the JSON for health checks UI. And let me I just copied it over here somewhere. Okay. So in here, I can add a collection of health checks. So in this case, my nightlife application relies on my 3 services. And so I've configured those 3 services to call out to that health endpoint, which if you recall, basically just returns this JSON. And this middleware UI is set up to consume that JSON. And so I've added my 3 services. Obviously you can just keep going with this, but I've added my 3 services. And now I will start this. And now I see my 3 services and I see the health of them. Underneath each one, I can see what dependencies I've added. So I didn't add any dependencies to weather or drinks. Dad jokes, we saw that I did add one to that external joke API. I want to add one more to the dad jokes, one more dependency. So I'm going to go back to the startup, and I want to add one more dependency here. And I'm going to add a dependency to one of my other web services. So this is nothing new, just the same as before. I'm going to add another URL group here. Copy and paste this. All right, so this one, port 5001 is just my local host for my weather service API. This guy here. So get back there. Okay, so I just added one more dependency. I'm going to go ahead and save that and build it. Oh, there's my Amazon package. All right, and I'll run this again. Here's my nightlife application. I'll go to the health dashboard. All right, same thing, except for now when I span this, I can see my second weather service API in there. And so what I'm going to do now is I'm going to shut down. I'm just going to stop the weather service API on my local machine, and then we'll see what happens. All right, so I've shut it down. All right, so we see the weather service API is now unhealthy. No connection. And also the dad jokes API now is unhealthy. If I expand it out, my external jokes, it's fine, but it shows my weather service API is now unhealthy. So you can kind of see those dependencies if you do have dependencies. So again, like imagine having SQL Server in here and Redis and anything that your service depends on. If there's an issue with the service, it's really easy to drill down and see what the underlying issue is. Okay. And finally, let's see, I'm coming up on time. So the last thing I do want to show though is, well, there's a couple things. I'll make this quick. All right, so another thing that this library offers is publishing events. So we want events driven. So when our health check fails, we want to push those events. And again, there are lots of pre-built publishers. So that, well, there's a few pre-built publishers, and then of course it is extensible, so you can write your own. So like if you use Datadog or Application Insights, rather than writing your own custom dashboard, you can push events to there. What I'm going to show you is a Slack integration, and so you may have noticed that you can in this UI, in this dashboard, one of the things that it has is is webhooks. So how do we configure those webhooks? I will show you. That is, again, in this configuration, we can just add that to this configuration. So I've already got a Slack channel set up. So all I need to do is add that into the configuration. So the webhooks, I give it a name, URI. So this is, if you guys don't use Slack, basically you go into Slack and you say, generate me a webhook, and it gives you this URL. You give it the payload that Slack is expecting. Take this chance to comment on a couple more of these properties. Evaluation time, this is how many times it pulls your health endpoint, and this is how many times the notification gets sent. So wait 30 seconds before it sends another one. Okay, so we've configured that. I'm going to start this again. Oh, didn't like something. All right, so here's my my health check. Now I can see I've got a webhook set up. And if I open Slack, there we go. Okay. So I've got this channel here, and I'll just see if I can share. So many screens. There we go. All right. And then what I'm going to do is I'm going to go ahead and shut down the weather service API again. Okay, so I've shut it down. And there I just received a message saying the weather service. And also I received a message saying the dad jokes, because again, the dad jokes, I've built the dependency on the weather service API. So there it's complaining that both are down. And then I'll start up the web service again. The weather service, I should say. Okay, I've started it. So now they're both healthy, and it's reported back to my Slack push notification that dad jokes is healthy and the weather service is healthy. I think that's about all I have time for. Is a couple. I'm just gonna rattle through a few things that I think are really impressive too, that you could look up on your own. So some other things that we can do with this is you can add additional endpoints. So in the startup here, where we added our health endpoint, we can also add like liveliness endpoints, and that allows us to work with, if we're running in containers and we have an orchestrator like Kubernetes or something, and we can configure it. You know, those have kind of this liveliness, and so it knows, okay, you know, maybe that particular endpoint doesn't care that the dependencies are down. It only cares that the service is up and running, because if it's not, then Kubernetes is going to restart that container. You know, if there's a dependency down, then restarting the container is not going to help. So we can actually add additional endpoint here, that like liveliness, and then have that have our Kubernetes or whatever we're using for our orchestrator point to that. And then in addition to that, you know, like I say, you don't want this to hit all of your checks. You only care about some of them. And so you can use a predicate here where you can say, you know, only run my checks that start with something. Or you can also, in here, you can supply tags. There's a tags parameter where we can tag it. And so you can filter these endpoints by tags or by prefix, so that, okay, this one only runs one of those tests, where this one runs all of them. And then the other thing is using it in release gates, like in Azure DevOps. So if you want to add an automatic failback, rollback, you know, using this, there are plugins to DevOps which will also connect to this. If it deploys, sees something unhealthy, then it automatically, you can roll it back to the previous release. All right, so that concludes my presentation.
All right, thank you, Ben.
Sure.
We'll roll right over into Philip's presentation.
Cool. Thanks, everybody. Hey, everybody, it's good to be back. I was just looking through my old presentations, and the last time I was able to speak at the user group was in July of 2008. And so it is good to be back and be able to present again. So this is a lot of fun. One thing I would like to plug right away at the beginning is if you have not, please go out to the user group website and send Brian and Matt an email thanking them for running this for as long as they have. I know that it is a lot of work when you're doing it on a volunteer basis and you've got family and work and other things going. So please do that for them. Give them that encouragement because it's so great to have a user group in town, and it takes people to keep it going. I'm going to send something into the chat real quick. This is the location of the slides. The slides is basically a markdown document and the code that I'm going to be using tonight. And so you can have that. You can walk through it with me. You can have the slides. You can look at it later, obviously. And that way, I'm just going to present all from that too. So I don't have anything else extra special. But let me jump into, let me share my screen here.
Philip, you don't look a day older from 2008, by the way.
Oh, thank you. Thank you, Ben. So yeah, let me just get started here with a little bit of background on what brought about my presentation. One of the projects I got to be involved with here at Orion was helping to move some secret values and some settings out of our config files into a secure store. I'm sure everybody has values in config files and different places that might be more secretive or something you might want to be able to control environment to environment. We've probably gotten really good at config transforms and different tools to sub in those values as they move throughout the different environments that we deploy to. And this is one thing that we had implemented to solve that particular problem. So I just wanted to start here with the code that's checked in there on GitHub. I've got two different projects. I've got a console app and a web app. And right now they've got some settings and a secret inside of a config file. And so what I'm doing is I'm taking advantage of the settings feature that's been in .NET, I think since .NET 2, that just allows me to have name settings. And so I've got a setting and a secret. Their values in the, as far as this dialog is concerned, is default. But when I actually go to my config file and I look at those, I've got my setting is from the file and my secret is from the file. And then the code that I have is just reading that out of the settings, default, my settings, and my secret. And so if I F5 on here, our console runs and we should see from file for both of those. And so really the goal now is to get those out of the config file and get those stored somewhere that is secure, that I have access to, and that maybe as I go up from testing to production, maybe increasingly I don't have access to production because maybe I shouldn't be seeing those values. So let me bounce over to here. And so kind of the main concepts that we're going to look at in this talk are, one is the Azure Key Vault product. And so the Azure Key Vault is something in your Azure subscription that's great for securely storing secrets. And if you have a value that's not necessarily a secret, but kind of changes from environment to environment, or you want to get it out of your config file so that you can change it dynamically or over time in production, the better option for that would just be the Azure App Config Store. And it's just a place to store key value pairs as settings or feature flags to turn things on and off. And the other thing that we needed to take advantage of was something called configuration builders. And a configuration builder is some native .NET code that reads from the config file and then gets the configuration from an external source. So I've got a couple of links where you can learn more about those. But these have been in .NET for a while, and then there are now config builders that allow us to talk to Azure Key Vault and Azure App Config. And again, these are probably more used if you do have an on-prem app. And so I do have in the code, I've got the console app, I've got the web app. You could see both of those. For time tonight, I'm probably just going to go through the console app, but the same things would apply to the web app. So we need to get a few things going and set up here in Azure. So let me start running some commands and we'll talk about those. So the first thing we're going to do is log in. We're going to create a new resource group named user group demo. We're going to create a key vault named user group keys 1. We're going to create an app config named user group config 1. And then we're going to create a new user named user group demo SPN. So we're going to run all of those. Let me just do the login first. All right, so we're all logged in. Let's run a few commands. So creating that user group demo. Then we're going to create our key vault. This will take a little bit of time because it's going to set up some of that secure storage. So this is probably the only one that's going to have that running. And while that's happening, the next thing we're going to do is we're going to set up a policy once we get the ID of that of our service principal name here. And then I guess let me talk a little bit about what we'll be doing after that. We need to go into our key vault and we need to set up the permissions on the key vault for our SPN, and we need to go into the app config and set up the permissions there too. I wanted to go through the UI on those instead of scripting those out because I think it is important to see some of the UI, but some of this other stuff we can just leave with the script. So here we're going to get our SPN. I'm going to copy a bunch of this stuff into Visual Studio just kind of for safekeeping. We're going to need that. So we've got our ID now. And we're going to set up some permissions on the key vault. And the permissions that we're setting up are the get and the list permissions. And we'll check those in the UI, but these are the important permissions to remember. Also, when I set up this SPN, I did this skip assignment, and this does not give any permissions by default for this user group demo. And the nice thing about that is because this has no permissions, I'm not too worried about these values here being recorded in the Teams recording because this person was set up with no permissions and they're only going to have the permissions that I give them in the next few screens. So when I started out here, I didn't have our resource group. Let me refresh this and we've got our demo resource group. We have our two resources, our key vault and our app config. We're going to start in the key vault, and the first thing we'll do is set a permission for that user group. Sorry, the user group SPN. So we're going to add a role. We're going to give reader access to the user group user. And then we can look at our role assignments and we can see here that the user group demo SPN is now a reader. And we can also go to our access policies. And here's where I said that you'd be able to see those get and list. Here's some policies that we applied through the command line, and that's how they got into here is get and list. And we applied that to this SPN. While we're in the key vault, we're going to go ahead and set up our secret. So let's create a secret. It's going to be my secret. And the secret You'll all get to see the value in a little bit. So we created that secret. We're going to go back to our resource group. And this time we're going to go to our app config. And again, we'll start here with the permissions. We can see in the role assignments, there's nothing right now. We can do an add role assignment. We're going to do the app config data reader for the user group. User. So now we've got this role assignment for our user group is now an app config data reader. And we're going to set up our config values. So remember, the app config is a good place for just any key value pair that's not necessarily a secret, stuff that can be stored in plain text. Out here, we'll create my setting. And we've got our setting. So we can show that value. We can see that my setting is a user group setting. What's neat about how the Azure config builders and the key vault and the app config work together is instead of having one URL to go for some settings and having another URL to go for other settings, what I can do is I can link these by doing a key vault reference. And that way I can just have one URL to get both secret things as well as just setting things. So we can set up a key vault reference here. I'll name this key the same as the key in the key vault. And we'll link out to that key vault. The key vault does need to be, we do specify the resource group, we get the key vault, and then we get to specify the secret that I created. And when I show the values for that one, you can see that the value that's returned is a link off to where the secret is stored. And so my user, the user that I'm running the app as may have rights to get out to the app config, but they also have to be given rights on the key vault. And so that way the key vault can be fairly securely managed because people who manage the key vault would know exactly who has rights to get to these keys. And it's not like I can bypass those rights, those permission settings and role settings without somebody knowing. Okay, so I think we have our Azure all set up. So we've created our Azure resources, we created a secret key, we created a setting for the secret key, and we created a setting. And now we're ready to get some of our code ready to talk to Azure. So I've put out here a few of the new Git packages that you'll need to reference. What makes them nice by doing it this way is we're able to just put those in the package manager. So my project is the demo console, and let's go ahead and install some packages. Cool. So now I have all the packages ready to go. And the next thing we need to do is start wiring up the config builders. So if we look at the app config again for this, this would just be a standard .NET app config, which allows the program to read values from the local config. We need to specify a config section handler because we need to have a config section to configure the config builders. And the config builders that we're going to link in here is the one that knows how to go out to the Azure app config. I'm just going to replace this one here. So let me talk about this real quick and why this is set up in this way. You are able to specify more than one config builder in here, and you're able to chain them, which is really powerful. And so Microsoft has created all different types of config builders. I have those linked out in the markdown file. But one of those that we use at Orion is an environment config builder. So you're able to pull config values right out of the environment. We have several of these chained together to go to different environment endpoints. So for example, we pull a bunch of settings from dev, and then we could pull a bunch of settings from test. And the way that that works is any section that we'd like to be configured, we just add on here a config builders attribute. And then we add on the name of the config builder. And you notice that that is plural, and that means you could chain these together. So if we first wanted to pull any values from environment, we could pull values from the environment config builder, and then anything that's not replaced, then it would move on and then pull any remaining values from the Azure settings.
So Philip,
Next
what
thing,
happens if
yeah.
they're in both
Yeah.
environment variables and in the Azure config settings?
Yep. Good. Good question. Let me grab let's all look at this real quick. This is the syntax for doing a replacement. So if you remember, I named my setting. And then I named my secret. And those names, again, those names come from right here. So to Ben's question, what happens if they're in both? So if my setting only existed in environment, because environment is first here, on the first pass through this XML, this one would be replaced, but then this one would be left alone because environment, maybe it doesn't have this defined. And so then as this section is passed to the next config builder, this one would already be replaced with the right value. So it wouldn't have the $, curly brace. And so the config builders wouldn't even know what to do with that. And so it just leaves that alone because it's already been replaced. And let's say Azure settings does know how to replace my secret, then the engine would replace my secret and we'd be all good. So the question of if it's in both, it's really whichever one is first and gets first pass over this XML will get to do the replacement, and the second one won't even be notified about it because the replacement will have already happened.
Nice. So if you're working like on a local machine and you actually want to override some of those settings that are stored out in Azure, you could do that by entering them into your local machine's environment variables.
Yep, and that's a great
Nice.
use case of it. Is if I do have some local things like maybe my username or my role or a location on my hard drive that's different from the server's hard drive, you could do an environment variable. It also supports a JSON file, so there's a JSON file config builder. Maybe you have that JSON file in a certain location. That config builder would run first, and then you could pull all the rest of your values from Azure second. We do not have an environment config builder, so I'm going to take that out. And then the last thing I need to replace here is the endpoint name. So if I come back to Azure and I go to the main screen here, I can grab my endpoint. I can paste that right in here. And I think everything's set to go. I've told .NET that there's a new section. This section configures the config builders. The config builders have the attribute that will go ahead and perform any replacements that it can perform right here. And I just want to check my slides to make sure I haven't forgotten anything else. Yes. The last thing is about authentication. How are we going to authenticate my application to the Azure endpoint? And the interesting thing about the config builders is they use this default Azure credential class. And the most recent version of this class, Microsoft created this to try to authenticate you in as many ways as possible. And the reason they do that is they would like you to be able to use the default Azure credential class both when you're developing locally, so like maybe you have environment variables locally, or maybe you've deployed your application to Azure as like an Azure function. You don't want to have to change the code or have conditional compile constants or flags, things like that. So they would like to make this class as versatile as possible so that no matter how you're doing development, running unit tests when you're logged into Visual Studio, maybe like I did, I logged in through the Azure CLI. They've tried to make this very, very robust, and that way no code has to change when I'm developing locally versus deploying. So I am going to use some environment variables to configure my code so that it's authenticated correctly, and then I'll talk about this last note down here. So let me change my program CS. I'm going to set these environment variables programmatically, and they'll just stay set for the time that this app is being run. A lot of times you might choose to set these in your environment on your developer machine or on your build server or on any of your production, or testing servers. And then you wouldn't have these compiled in, but this is just so that I don't have any, I'm doing this just so that there's no secrets going on. Everybody could see this, but this isn't the way you'd do this for production code, but I don't want there to be any magic on how did I authenticate here. So the things we need the client ID. We need the client secret. And the tenant ID. And then these are set up, and then based on this order, it'll first check those environment variables, and those will be there. The right ones are ready, and so that's how I will get authenticated out to that endpoint. So let's go ahead and run it. So now instead of those values from file, we get a user group setting and a user group secret. Those are the values I typed out in Azure, and those were replaced at runtime, these placeholders, my setting and my secret. And that's pretty much it. Let me talk about this note, and then I'll take some questions. One other thing that you might notice is missing from this list is the Windows credential. And Microsoft does have a Windows authentication token provider, which can authenticate accounts that are on the domain. Microsoft chose not to include it in this class because that would be something very specific to Windows. And this is meant to be cross-platform for this class and this library. So the Windows credential is not included. It's actually something that we modified at Orion so that we could log in with domain accounts, and it actually made a much smoother experience for developers as they were developing locally. We didn't have to set up any environment variables. We didn't have to do interesting things with Visual Studio or IIS. We just had to make sure it was running as that user. And so we added that in because all of this stuff is open source. We were able to recompile a few things and add this in. And so there's even ways that you could enhance the solution to add on like Active Directory support. One last thing I'll say about the code is all of that stuff can be done to the demo web app. It's in the very same manner by adding the NuGet packages, modifying the config file, adding a constructor to the default CS to set up the environment variables, and then it too can talk to Azure. Any questions?
So using the Windows credentials, I think, is nice too, because one of the efforts that we're trying to accomplish is keeping those secrets secret, and by not having to pass out Azure app config credentials, secrets, and client keys. Just tightens that up once their Windows account, if it's closed or whatever permissions we want to give it. It has to be very explicit, and they're not just granted some generic keys that the application needs to use to have full access.
Yep, that's a great point, Ben. If we were to do it in this manner, I'd constantly have to be managing these keys, handing these out to developers as they come and go. Now these keys are basically the secret, and if everybody has them, then they're not really secret anymore.
Right.
What's nice about using that Windows credential is you know, the IT, the help desk and whatnot, as people come and go, or as people you know, move in or out of the department. All of that is just taken care of with one thing already, and I don't have any key management to do for all of our employees.